We're looking at collision theory as they relate to chemical reactions. And what we're going to look at, we're going to recognize that all particles are moving, and we're going to look that the average amount of kinetic energy of all particles in a substance is proportional to its temperature in degrees Kelvin. And for a reaction to take place, the molecules must actually collide, but not every collision between molecules is going to lead to a reaction. So it must be a successful collision for the reaction to take place. And we're looking at the reaction then occurring with sufficient energy. There's going to be a minimum amount of energy for the reaction to take place, and that's the activation energy EA. So the reacting species is going to have an energy greater than the activation energy. So the particles must collide so that bonds can be broken and the reactant can be changed into the product by making new bonds. During the collision, the particles must approach each other, collide in the correct way, called the correct collision geometry. So they must be moving in the right direction. Glancing collisions will not result in a successful reaction. So here's a schematic of a reaction. You've got a diatomic molecule A2 reacting with a diatomic molecule B2, which is going to end up with two molecules of AB. So during the collision, the particles must approach, and if they do so in this direction, it won't be successful, nor indeed if there's an end-on collision in the center, end-on collision at the top, a glancing end-on collision at the bottom of a molecule, or an angled end-on collision. And we can look at lots more different ways of colliding, sideways collision of the second molecule. What you actually need is a direct hit of the particles with the correct amount of energy colliding for a reaction to occur. So you're going to form a reaction intermediate. So you haven't got the reactants, you haven't got the products, and so this is the activated complex of A2 and B2. And then the bonds between, in the diatomic molecules, the vertical bonds shown here are breaking, and the horizontal bonds between the two atoms A and B, top and bottom, they are making the bonds. So again, looking at the formula, what is happening. So we're getting the correct collision, and the rate of reaction is really the number of successful collisions, how much product is made during a unit of time. And important to mention that only a small fraction of collisions will lead to a successful reaction. And here the figure is about 1 in 10 to the 13. So three characteristic properties are going to be the frequency of collisions, the kinetic energy of the particles that are moving together and colliding. That has to be adequate above the activation energy, and there has to be a correct collision orientation or geometry. And the exercise here is to look forward and list as many factors which affect the rate of reaction.